Hello Williston Scholars, and welcome to another video of BC Calculus with your host, Henry Lombino. Alright, today we're going to be looking at 11.3, which is Euler's formula, Euler's method. So what this is used for is basically to calculate or estimate differential equations. So if you have a really messy differential equation that you don't really feel like finding the actual value of, you can use this to estimate it. So we're going to look at that today. So what we have here is our differential equation is right here. So we have our dy dx and what that equals, and then we have our initial amount. So the way we're going to use basically what Euler's formula is you go step by step through the process and calculate the slope at each point, and you move up in a certain amount of a certain change of x. So for our first part of this problem, we're going to be estimating this with 2 steps, then we're going to be estimating it in 4 steps. Then for the second part, we're going to be looking at we're going to calculate the actual value and compare our findings for both of them. So let's look at with 2 steps now. So what we're trying to find here is we're trying to find what y equals when x equals 1. So that is what we're trying to find out. So the first time we're going to do that is we're going to estimate it with 2 steps. So we're going to have 2 different values of x. So we have the initial value of x, which is x equals 0. So that would be, that'd be step 0. But now we need to find the other 2 steps. So we need to have the other 2 steps. So we're also going to calculate when x equals 0.5, and of course the ending amount when x equals 1. So that's going to be our first part. So the way we're going to do this, let's make a little chart for us to help us organize our thoughts. Alright, so there's our chart. So what we're trying to calculate here is we're trying to find the change in y for each step, so we know how much y goes up for each time x goes up. And we do that by calculating using this equation right here. The change of y is going to equal m times the change of x, and m is the slope. M is the slope. So m is going to equal dy dx, which is going to equal, and we have it over here. I'm sorry, I should have made this full screen. And we have that over here. It's equal to 2x. So dy dx is equal to 2x. So for each point, we're going to plug in the proper amount to find the change in y. So let's do that right now. So let's calculate our first change in y. So the change in x equals, m times the change of x equals the change of y. So what is m? Well, m, we have x equals 0, so we plug in 2. So we plug in 2 times 0, which equals 0. So which times 0 again is equal to 0. So the change in y right here is just 0. So y doesn't do anything right here. So we go to the next value. So we can fill in this next value. Y is still going to stay 1 right here. So that was easy. 0, 0. So that was pretty easy. So now it gets a little more complicated. Now we have an actual value for x. So let's solve for the second time. Now we have to find m. So m is going to equal 2 times this x value, which is 0.5. So which is going to equal 1. So we have 1 times the change in x. Now if we go back, we know that every time that this is increasing every time by 0.5. So the change of x is 0.5. So we're going to multiply this by 0.5, which is going to get us an answer of 0.5. So the change in y is equal to 0.5. So now we can put that in for this last one. We add 0.5 plus 1, which gets us 1.5. And there's our answer. We now know that y, from this right here, we know that y of 1 equals 1.5. That's our answer for that problem. Now when we do this with 4 steps, we're basically going to do the exact same thing, except that the change in x is going to become smaller, meaning that our answer is going to be more accurate. So I'm just going to do that out right now. Okay, so now this is with 4 steps. So now we've changed the change of x into 0.25. So now we have 4 steps to calculate at. So our m is still equal to 2x. So let's start plugging this in right now. So first of all, our change of y is equal to, if our x is equal to 0 right here, it's going to equal 0, and then our change of x is 0.25 right here, so that's going to equal 0 right there. So there's no change in y for this one, so it still equals 1. Now for the next one, we're going to plug in 0.25 into the m equation. So we're going to get m equals 2 times 0.25, which is going to equal 0.5. So that's our m right there. And then we're going to multiply that by our change. So we're going to have 0.5 times our change in x, which is going to be 0.25, which is going to equal 0.175. So that's that right there. So okay, so now our change in y is equal to that. So we're going to add that onto 1 because it's a change in y, and it's going to go and be now 1.175. All right. So now let's do it again. So now we plug in 0.5 over here. We get 1 for our m. We get m equals 2 times 0.5, which is equal to 1. So we have 1 times 0.25, which is equal to 0.25. So that's our change in y again, and then we're going to add it onto here. So we have now 1 point, and this is going to equal, doing the math in my head, is going to equal, I believe, 1.425. So, and basically, so I'm not going to, and then we do it once again. We plug in 0.7. We plug equals m equals 2 times 0.75, which is equal to 1.5. So now we're going to plug that in here. We have 1.5 times the change of x, which is 0.25, which is going to equal 0.375. And actually, guys, I just realized that I made a mistake up here. This is actually 125, which changes a lot. So now this is 125. We add this, so this actually is going to be 375. I'm sorry, there's a lot of, that's just, guys got to watch out for that, because you make a little error and then everything goes kaplush. All right, so now we have, so now we add this so now we have the change of x equals, at this point, equals 0.375. We add that to 1.375, and we are going to end up with where are we going to put 1.75. So there we go. There we have it. So now, by this estimate using Euler's formula, we have y of 1 equals 1.75. So that's our second estimate. Now let's compare this to the actual amount, the actual answer. So let's do that. So we know from this that dy dx equals 2x. So let's turn this into an integral. So let's turn this into an integral. So we're going to have dy 1 dy equals 2x dx. We're going to integrate both sides. We're going to have y equals x squared plus c. And we know that from all the way up here, this initial amount right here, we know that y 0 equals 1. So we're going to plug those in. We're going to do 1 equals 0 plus c. So 1 equals c. So the actual equation for this is going to equal y equals x squared plus 1. That's our actual gain. Now, of course, with the place where you normally use Euler's formula is if you couldn't make this into find the actual equation for the problem. You would have to estimate, but we can actually. So what this allows us to do is actually compare the actual answer. So the actual answer of this for so y of 1 actually equals, so we have 1 squared plus 1, which is equal to 2. So let's compare. So now we have our two. So we have our two answers. Those are our two answers. So now we have our two. That's actually about equal to. We have our two different answers. We have our actual answer, and we have our estimated answer. And you can see they're different, but. And if you remember even further ago, we had our answer up here. Woo, oh God. When we estimated using just 2 steps, we had y of 1 equals 0.5, 1.5. So 1.5. So you can see as the steps, so this is with 2 steps. This is with 4 steps. So you can see as we use more steps, our number becomes more and more accurate. And this is the actual. So, and gets closer and closer to the actual equation. So, in general, you want to use as small steps as possible, then your accuracy will increase. So yeah, so that's how you use Euler's formula. Just remember to use this chart right here. Because this is a recursive function, it's really important you check all your counts, your numbers, because like what I did is that if you mess up one, then everything is screwed up. So you really have to be very, very careful there. So yeah, so that's Euler's method. Hope you guys enjoyed this video. All right. Bye.